Dear students, welcome to the fifth module of Carbon Compounds chapter. The objective of this module is it aims to explain and make students understand about the chemical properties of carbon compounds. The properties that are going to be discussed today are combustion, addition reaction, oxidation and substitution reaction. We will begin our today's session after recollecting what we have learned in our previous module. In previous module, we have learned that the International Union for Pure and Applied Chemistry has put forth a nomenclature system based on the structure of the compounds. The IUPAC name of any carbon compound contains three units, that is parent, prefix and suffix. The order with which it is written is prefix first, then the parent name, and then comes the suffix. A halogen's name is added to the prefix and other functional groups are added to the suffix. Let us learn about the chemical properties of carbon compounds by brushing up our previous knowledge. Which is the component of biogas that makes it useful as a fuel? You have learned about it in your 9th standard. It is methane. Which product is formed by combustion of elemental carbon? It is carbon dioxide gas. Is the biogas combustion reaction is an endothermic or exothermic? Children, what is endothermic? Endothermic is a chemical reaction that uses up heat, that takes in heat. And exothermic is a kind of chemical reaction that liberates heat. So, is the biogas combustion reaction endothermic or exothermic? Certainly, it is an exothermic reaction where heat is liberated. Heat evolves out of the chemical reaction. So, we will see about combustion. The hydrocarbons and most of the carbon compounds, they undergo combustion in the presence of oxygen to emit heat and light and form carbon dioxide and water as common products. If you see, when you are burning elemental carbon, that is only carbon with oxygen, the gas carbon dioxide alone is released with heat and light. But if you are burning any hydrocarbon, it means that there is a presence of hydrogen atom. Here we have taken methane, which undergoes combustion with oxygen and produces carbon dioxide as well as water vapor along with heat and light. If we take any higher order carbon compounds along with a functional group as well, the products are same, that is carbon dioxide, water, heat and light. This case is true for any homologous series with any number of carbon compounds. Now we will see what will happen when we burn ethanol and naphthalene. Ethanol is an alcohol, you know, and naphthalene is nothing but the naphthalene balls that we are using to get rid of the bugs. See, when there is oxidation, a saturated hydrocarbon burns completely. If the hydrocarbon is a saturated one, it burns completely with a blue flame. Examples of saturated hydrocarbons are ethanol, LPG, but unsaturated hydrocarbons, they cannot be burnt completely. So what they do, they emit a black smoke. For example, you imagine burning of naphthalene, even camphor and wood, they definitely emit a black smoke. That black smoke contains a fine black particles called soot as well. Here you can see a blue flame. This blue flame is very common when you switch on the LPG gas stove also. This is because they are composed of saturated hydrocarbons. But when you burn unsaturated hydrocarbon, the color of the flame itself will be an orangish red and yellow combined with definitely with the emission of a black smoke, also along with small fine particles of black color dust called soot. If there is a limited supply of oxygen, even saturated hydrocarbons also produces a yellow color flame. What happens in an oxidation reaction? A carbon compound completely get oxidized during combustion. We have seen in combustion reaction. There are some substances that give oxygen, that donate their oxygen atom to other substances. Those substances are called oxidants or oxidizing agents. Potassium permanganate or potassium dichromate, these two are commonly used oxidizing agents. What does this do? This oxidizing agent affect certain functional group present in the carbon compound. So that carbon compound gets transformed. We will see an example of oxidation reaction. Here you are seeing conversion of ethanol to ethanoic acid. When potassium permanganate, this is the formula for potassium permanganate, is mixed with ethanol, it forms ethanoic acid. See, when you see only certain bonds in the vicinity of functional groups, the one that is near the functional group, take part in this reaction. You can clearly see an oxygen atom gets added with this carbon, that is the carbon that contains the functional group, and gets converted into an acid. A potassium permanganate contains a pink color. Okay, when this potassium permanganate is added with the solution of ethanol, it disappears in the beginning because this oxygen in the potassium permanganate is getting used up to convert ethanol to ethanoic acid. But at certain point, when every single molecule of ethanol has been converted to ethanoic acid, the oxidation of all the ethanol in the test tube is complete at certain point. If we are adding potassium permanganate, even after that point, that potassium permanganate, it becomes excess. So what happens? After that point, the pink color will not disappear, but it stays as it is. So at this point, we should understand that, okay, the conversion of ethanol to ethanoic acid has been done, or the oxidation reaction is complete now. The next reaction we are going to learn is addition reaction. When a carbon compound combines with another compound and forms a product where it contains all the atoms involved in the reactants, then it is called an addition reaction. Simply we can say we are adding up two different compounds. See, unsaturated compound contains a multiple bond as their functional group. We know that unsaturated compound contains either double bond or triple bond as their functional group. What they do, they undergo addition reaction to form a saturated compound as a product. See, the addition reaction of an unsaturated compound happens with iodine or bromine. This reaction takes place very fast, instantly at room temperature itself. Using this tincture or bromine, let us see how to test and find saturated or unsaturated hydrocarbon. What do we require for this experiment are either tincture iodine or bromine water. We take liquefied vanaspati ghee because we know that vanaspati ghee is of some solid state. If we want to do that experiment, it is better to heat it up and take it in a liquefied form. Along with it, we need various vegetable oils like peanut, safflower, sunflower, and olive oil, etc. The procedure is we have to take about 4 ml of any of the vegetable oil in a test tube and add 4 drops of tincture iodine or bromine water and shake the test tube well. You have to wait and find out whether the color of bromine or iodine, which is a brown color, whether it disappears or not. Then repeat the same procedure using other oils and finally vanaspati ghee as well. If you see, the color changes instantly with unsaturated hydrocarbon, which can be easily felt by the eyes. Therefore, this reaction is used as a test for detecting the presence of a multiple bond in a carbon compound. If you see the color of iodine or bromine, it disappears when reacting with vegetable oils only, but there will be no color change with vanaspati ghee. So from this we understand that vegetable oils, that is peanut, safflower oil, sunflower oil and olive oil, they are unsaturated hydrocarbon. They contain a multiple bond, whereas vanaspati ghee is a saturated. It lacks a multiple bond. It is a saturated hydrocarbon. So this is a easy test to detect the presence of multiple bond in a hydrocarbon. Let us see the iodine and bromine test for some other hydrocarbons as well. The first one you are seeing in the table is stearic acid. This is the structure of stearic acid, where you can find all the carbon atoms are linked with each other with a single bond. So you don't see any double bond. The number of carbon-carbon double bond is 0. Will it decolorize iodine? No, it will not decolorize iodine. The next structure we are seeing is oleic acid with the formula C17H33COOH. You can see the presence of a double bond in oleic acid. There is one double bond. So it will decolorize iodine. The next hydrocarbon we are seeing is palmitic acid with 15 carbon atom. As you can see, all the carbon atom are linked only with a single bond. It is a saturated hydrocarbon with no double bond. So it will not decolorize iodine. Finally, we have linoleic acid. Here you can see the presence of two double bond. So there are two double bond. It is an unsaturated hydrocarbon. So it will decolorize iodine. So what will happen when the addition reaction happens with hydrogen? The unsaturated compound undergo addition reaction with hydrogen also to form a saturated compound, but this happens only in the presence of a catalyst like platinum or nickel. This hydrogenation of vegetable oil happens in the presence of nickel catalyst is helpful to produce vanaspati ghee. We have seen in the activity that the iodine test indicate the presence of multiple bonds in the molecules of oils, that is vegetable oils only, while vanaspati ghee is saturated. The molecules of vegetable oil, they contain long and unsaturated carbon chain. This hydrogenation with hydrogen, it transforms them into a saturated chain and thereby vanaspati ghee is formed. We know that unsaturated fats containing double bond are healthy, while saturated fat are harmful to health. If you can see this image, this is a blood vessel. We know that the blood vessel contains minute pore for the exchange of materials. If you see, there is a deposit of fat inside the blood vessel and it is blocking the flow of blood. We know that saturated fatty acids are lighter. So what happens? These saturated fat manage to get into the pores of the blood vessel and gets deposited in the walls of the blood vessel, hence blocking the blood flow. So this condition is called atherosclerosis. This is why it is said that saturated fats are harmful for health. In the other case, the unsaturated fats, which are generally thicker, will not pass through this blood vessel. Okay, so that is why it is said unsaturated fats are good for health, where saturated fats are harmful to health. Now we are going to learn substitution reaction. The single bond, that is the single bonding between carbon and carbon are very strong compared to the double and triple bond between carbon and carbon. If you see the saturated hydrocarbons, they are not reactive. Therefore, they remain inert in many cases in presence of a reagent. But when you see the saturated hydrocarbons in presence of sunlight, they react rapidly with chlorine. In this reaction, the chlorine atoms replace the hydrogen atoms one by one. The reaction in which the place of an atom or group of atom in the reactant is taken by another atom or group of atoms is called as a substitution reaction. The chlorination of methane is a substitution reaction which gives four different products. We will see them one by one. The first reaction is between methane and chlorine, where one hydrogen atom from methane is taken and joined with one chlorine atom forming hydrochloric acid. The other product formed is methyl chloride. This methyl chloride will undergo chlorination again to form dimethyl chloride. The change is similar to the first reaction, removal of one hydrogen and one chlorine and making hydrochloric acid with dichloromethane. This dichloromethane will again undergo chlorination to form trichloromethane and hydrochloric acid. This trichloromethane has the common name chloroform. When this chloroform reacts with the chlorine, the final product formed is carbon tetrachloride with the formation of hydrochloric acid. So students, hopefully now you understood what is meant by substitution reaction. If a single carbon compound methane can form four different products on chlorination, we can imagine the number of compounds that we will get with higher order alkanes. So children, that's all about the chemical properties. We will summarize the points one by one. The hydrocarbons and most of the carbon compounds, they undergo combustion in the presence of oxygen to emit heat and light and forms carbon dioxide and water as the common products. The carbon compounds completely get oxidized during combustion. There are some substances that give oxygen to other substances. They are called oxidants or oxidizing agents. When a carbon compound combines with another compound to form a product, and the product contain all the atoms in both the reactants, then that reaction is called an addition reaction. Unsaturated compounds, they undergo addition reaction to form a saturated compound. The reaction in which the place of one type of atom or group in a reactant is taken by another atom or group of atoms is called as substitution reaction. Chlorination of methane is an example of substitution reaction which gives four products. So children, that's all about the chemical properties. We will see the rest of the chapter in the coming modules. Thank you so much.